Alright, hello once again, this is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations for Murachs, JavaScript, and jQuery, 3rd edition. I'm up to Chapter 5 of 18, and Chapter 5 is on how to test and debug a JavaScript application. You'll notice we have quite a few more applied objectives. This is a very hands-on chapter. Develop test plans for the applications you develop. Use top-down coding and testing to simplify debugging. Use Chrome's developer tools. Trace execution of an application with console.log statements. View the source code of a web page and validate the HTML for a page. Our 7 knowledge objectives: distinguish between the goals of testing and debugging. Distinguish between the 3 major types of errors, those being syntax, runtime, and logic. In general terms, describe the way you create a test plan. Describe the type of debugging problem that can occur when you use floating point problems in arithmetic expressions. And describe one way to fix this problem. Describe the type of debugging problem that can occur if you don't use script mode, so JavaScript treats undeclared variables as global variables. Explain how top-down coding and testing can be used to simplify debugging. And describe the procedure for tracing the execution of an application with console.log statements. Now, one of the major things in the chapter is on this slide right here. Sounds simplistic, pretty much is simplistic. When you test a program, you are trying to find every error that exists in the program before it's put into production. So the idea is when you test a program and you can break it and find errors, that's considered a success, not a failure, because it's much better that you find the failures, that you find the errors, than have this go into production and then find the errors. All right? Okay. Once you find the errors, the act of fixing those errors so that the application works, that's debugging. As far as the types of errors you can get, there are 3 major types. There are syntax errors. Syntax errors violate the rules of the language. There's several ways that you can get syntax errors. All right, for example, if I'm using the word alert, and instead of typing in alert, I type in something like allet, let's say. That's going to be a syntax error. All right, runtime errors. Okay, and a runtime error, an example of that would be if I declared a variable and didn't give it a value and then tried to print it out. All right. A logic error, that's the hardest one to find typically, because most of us programmers consider ourselves to be infallible. With a logic error, an example of that would be adding 2 numbers together when you mean to subtract one from the other. So here's the future value calculator, and as it says, the calculation shows an incorrect result, which can be hard to identify. All right. Well, one thing is, if you're making 7%, this is taking what you have and almost doubling it. So something is wrong in there. All right, so you have to start going through and finding different kinds of errors that you can get. There's an example, misspelling keywords. That's probably the biggest one. Get element by ID and making that D a big D. It won't work if you do that. Omitting parentheses when they're required. Omitting quotation marks, or starting with a single quote and ending with a double quote, or vice versa. Forgetting braces when they're needed. Omitting semicolons at the end of statements. Misspelling something, or goofing up the capitalization type of thing. Referring to an HTML value or other component incorrectly. As it says, if you gave something an ID of sales tax with a big T, and then you refer to it in code with sales tax with an underscore and a lowercase t, it's an error. Problems with data and comparisons, not testing to make sure the user put in the right type of data before you process it. Not using parseInt or parsefloat to do the conversion. Using a single equal sign, which is assignment, rather than the double equal sign, which is test rate quality. All right, floating point arithmetic problems. What they're saying here is if you take 74.95 and multiply it by 0.1, you don't get 7.495. You get 7.495 with a boatload of zeros and a 1 on the end. All right? And the reason that you get that is because floating point math internally in a computer is an imprecise science. One way to fix that is to just do it to 2 decimal places and then convert it back. Problems with undeclared variables, we've already talked about this. As long as you make this var inside of here and you put the word var in there, it's a local variable. If you forget the var and you put it in there, it's a global variable. But the problem is, this is sales tax with a big T. Then this is sales tax with a lowercase t. What happens is the system actually creates 2 different variables because they are technically spelled differently, because with this being a case-sensitive language. So this has the value of sales tax that's been unformatted, and the other one has the value of sales tax after you did a parse float on it. Okay? The solution to the problem, as the author says, is to always use strict mode. So here's the future value with valid data. All right? It's very important when you're testing things that you should go over, for instance, if I'm creating a future value calculator, I should go back here and do something like this and come up with a few examples by hand. Or go online and find a future value calculator, put in some values, and then run my own program to make sure that my answers jive with the, quote, official ones, unquote. So there's the future value calculator where we've accounted for invalid data. The 2 critical test phases that they talk about here, when you test, you're going to test in 2 different ways. The first thing, of course, you should always do is to test with valid input data to make sure your program reacts and acts the way that it should. Then you come up with every invalid type of input you can think of and you try to make it fail. Now, quite often what you do and what you really should do is you should make a test plan where you say, okay, these are the most critical areas of my code. So I want to test the heck out of them to make sure that it's not in any time doing something it's not supposed to do, it being the program. Common problems that people have with testing. The first one, they don't test enough entries. They test, but they don't do thorough enough testing. The second one, not knowing what the result of each set of entries should look like. So not knowing your program well enough that you actually know when you test what the answers should look like. They might even be correct and you're not sure they should be. So again, I can tell by looking at this that there is an error in the code. Why? Because we're starting with $75,000, and at 7% over 5.5 years, we're making 1.5 times what we had. So there's probably an error in that code. All right. So in the example they show on the screen here, and it's on page 149 in your book, what the author is saying is we're doing no validation right there. So if we put garbage in, there's a famous computer saying GIGO, garbage in, garbage out. So if we put garbage in, the system is glad to try to process that garbage input and give us garbage output. That's typically not what you're going to want to have happen. So we come in here and we start to do validation. We want to make sure, so we're saying if our investment is non-numeric or it's negative or it's greater than $100,000, we don't allow it. Otherwise, we do. We have to then add validation for our other entries. Anything that we're inputting from the user, all right, that says we could conceivably have bad data put into it. So we must write something like this for every input we have. Then we can do finishing touches like adding the focus to a text box at the beginning of the program or when a text box has an error, making sure that we clear out what's in the text box and put the focus there, etc. So test, test, test. All right. There is like an old programmer adage that says testing is a 3-step process. Test step 1. Test everything to make sure that what you think works will work the way that it, that basically when you have success cases that they work the way you think they work. Second, check every failure case to make sure that it works and is handled every way that it should. And third, go back to step 1. Every time you run a program, you are in essence testing it. All right, you cannot test a program too much. Debugging is getting the errors out. Each error is a bug. Throwing an exception we'll talk about in a later chapter, and throwing an error. And top-down coding and testing is when you start from the top and you work your way down, as opposed to bottom-up, which is doing it in reverse. All right, so Chrome Open Console panel that shows an error. Let's see if we can do this. All right. We won't use their example, but I'll tell you what we'll do is we're going to come in here and we're going to bring up our program, our calculate miles per gallon that we've been working with. I'm going to take all of this stuff where we created the date object and I'm just going to comment it out. We don't need that stuff for what we're doing now, so I'm going to remove that. I'm also going to remove that confirm box that I put down at the bottom. And then I'm going to introduce a few errors in here. So first, let's run it and make sure it appears at least to run correctly. All right. So enter miles driven, 300. Enter gallons used, 15. It should come back with 20. It does. It says, do I want to run it again? I'll say no. And it appears to work just fine. But now I'm going to come in and I'm going to introduce some errors. All right. So, for example, in here, I'm going to put gallons here with a big G, like that. All right. Now I'm going to run the program again. I'm going to save it and run it again. Okay, it still asks for my miles driven. Still asks for my gallons used. And now it stops. What the heck happened? Well, one thing I can do is I can now hit my F12 key, which will bring up the Chrome Developer Tools, and the system says gallons is not defined. And it's showing me that it's at index.html in line 31. So I go back to my code. I go to line 31. There it is. There's my G. All right. So I'll put it back, and now it would work. What if I come through here and I write, instead of to fixed, I write to frixed? All right. And I go in and I run the code. Again, it says how many miles are driven, 230. How many gallons were used, 23. And again, it stops. So again, I hit the F12 key. The system comes up and it says to frixed is not a function. And it says main is not defined, just mainly because it, well, we'll fix that in just a second. How's that? So I come back in. I changed it back, from my error I put in purposely from to fixed to frixed. All right. Now I come in and I hit F12. And I can't do it from here. I've got to be running the program. Wish I wouldn't have done that. All right. That's not what I wanted to do right there, but it's what I did. Okay. So now I come through here and I run the program. And as you can see, it appears to be working. And if I hit F12, I don't have any errors in here. So I come in here and I go in 23, or 230, 10, and 23. Everything looks good. No. Now it's saying it's going to uncaught reference error in main in line 49. So let's look. Line 49, we have this. And it says we want to call main. We don't anymore because that was back from an old program. So I'm going to take this line of code and I'm going to comment it out, and I'm going to replace it with just putting in a body statement without onload equal main. And then let's run the program again. All right, looks good. Let's hit F12. And again, we'll put in 111 and 10, and boom, miles per gallon. Do I want to run any more? Well, notice if I say no, I didn't get any errors here. So this, using the console area like this is a great way to go in and to be able to debug your code. Right? This is just a primer. There's no way in the amount of time that I have that I can go through and actually show you this, all right, in a lot of detail. Now here they used is NaN, but that N should be capitalized. All right, I showed you the easiest way to open the developer console. I don't care what they say here, is to just hit the F12 key. That opens it, hitting it again closes it. All right, there's a source panel in there that will show you all of your code. All right, so it says, let's go back and do what we did before. That is, let's go back and we're going to put gallons in here with a big G like we did before. All right, and now I'm going to go into a file, run it in Chrome. All right, I'm going to hit F12 again, okay, and I'm going to again put in, all right, it gives me that error, okay. If I go over, where is it here? To elements, I can take a look at all of the code that is in here. All right. Somewhere there's my gallons with a big G. All right, I can go to console and find the error right away and click here, and then notice when I clicked on the error, it's showing me the line in question. Okay, I'm not able to actually change it there, but it's showing me where the error is so that I can go back into my code and physically change it. All right. We can come in and set breakpoints. If you set a breakpoint in your code, just so you see this, if I click over here, this is called the gutter area. If I click over here, it puts a blue line there, which means it's a breakpoint, which means stop when you get there. All right, so let's look at that. Let's go back and we'll fix our code. So I'm going to make that gallons again with a little g. All right, and save it and run this again. All right, bring up my F12. Okay, 230, 23, and click. All right, it tells my gallons, and it says repeat. It doesn't look like it stopped though. So let's see where I put that breakpoint, or try to see where I put that breakpoint. Guess I'd have to go back in and do what I did before. That is to go back into here, put it in error. Okay, so we're going to assume that's where the error is. Run it, hit F12. All right. We get our, over to console, it shows us where our error is. Boom. Now it wasn't stopping on that alert, but we should be able to set a breakpoint anywhere we want. And then when we do, we can come over to here and we can look at the value. All right, it's showing us where our breakpoints are. All right, and we can stop and then look here in what's called the watch window in the call stack to look at the value of different expressions when the program stops. I wanted to mention to you, this is a site that I go to. I'm literally have probably taken 100 courses, if not more, from this site, and it's called udemy.com. All right, udemy.com. And notice if you go out there and you search for courses, and I'm going to put in here Chrome Developer Tools. All right, and I'm going to click that because I'm going to click under Price and Free. And they have a bunch of free online tutorials where you can learn this stuff, all right, in much more depth and breadth of coverage than I'm giving you. You can, when you're running your program, you can use these different what are called step modes to step into. So if you hit F11, it's going to run your code a line at a time. If you hit F10, it'll run the whole function, but it won't stop with each line. It'll go through the whole function and then stop. If you're in the middle of a function and you do a shift F11, it'll execute the rest of the function without stopping. And if you're stopped and you hit F8, it will resume again. So there's a lot of ways that you can play with this stuff. I already showed you the watch window, okay? The only way that you become proficient at debugging, shouldn't be a surprise to you, is to debug. All right, so you get better at something by practicing it. All right. You can also do what's called a console.log statement. So what does that mean? Well, notice what I'm going to do here. Let's assume that I'm working on a program and I'm having some kind of a problem with it. I'm going to fix that gallon so it's correct again. All right. So I'm down at the bottom here, and this gave me all of my answers right there. And I'm going to put in here console.log the miles driven was plus miles. Okay. Console.log the gallons used was plus gallons. And finally, console.log the miles per gallon was. And we will format it to make sure. So we'll say mpg dot toFixed 2. All right. What did that do? Well, at first when we run this, you'll think it did nothing, but just bear with me for a minute. So here's our F12, and I'm going to go to the console. All right. And I'm going to put in here 230, 23. All right, there's our miles per gallon. Now, where is it? I thought it would show it here. It says console is not defined. I thought it was console.log. It's console with a little c. My error. So what do I get? I get, again, hitting the F12 key and going over to elements, it shows me where my error is. I'm debugging. All right, so let's put in a little c here, and a little c here, and a little c here. File, we'll save it, we'll run it again. All right, hit our F12, 230, 23. All right, oops, I don't know what happened. Miles driven, 23. Gallons used, 1. All right, there's our miles per gallon. Why it's not showing us anything, I don't know. It should be logging it. And there was our log. So it's another way that you can print out information in the program to see if something is not working correctly. You can work with it to try to debug it and make it work correctly. All right. Okay. Just about done with the chapter here. There's the log message. If sometimes you go through a program and you just can't figure out what the problem is. All right. So you run this. You still don't know what the problem is. If you right mouse click where your run is and you choose view page source, it'll show you all of your code. All right. And if that doesn't work, you can copy all of the code to the clipboard, and you can type in here HTML Validator, and you can go out to the W3 markup service, validate by direct input, paste your code in and click check. And if there's a problem, it'll tell you it. Start head tag team. Seen, but an element of the same type was already open. So it already found 3 errors. So it said it didn't like something where my head tag was. So let's take a quick look. There's my head. Oh, I got another head tag right there. I didn't even notice that. So let's save it. Go back to where we just were. Back up here. Get rid of what was in here and put it in with only 1 head tag. And now it says title not allowed as child element of head in this context. Plus I've got a stray head tag in column 50. So we keep looking. Notice I've got 2 ending head tags. Get rid of that. I've got 2 titles. So let's save. Look at it again. Green is good. All right. Now that didn't help really with debugging, but it cleaned up errors that we had in the program. So another way that you can get extra information is to go in and do that. All right. All right. There is no exact JavaScript validator. All right. In fact, I can come in here and I can look for one. Okay. The one it's going to give me here is JSLint. And that's something that a developer wrote, so you can type in your JavaScript or paste it in, click JSLint, and it'll show you any errors. It's very, very unforgiving, just so you know. It likes things coded in a certain way, and if you don't do it, it flags it as being an error. So, let's see, I guess we're finished. All right. So, I'm done for today because my students are going to be coming in soon. But in the next chapter, we'll go through how to script the DOM with JavaScript. And following that, we're going to go into Chapter 7. Which is on how to work with links, images, and timers. After we get done with Chapter 7, that will get us through the first section of the book. And then we jump into jQuery Essentials. So I'll be back with both of those in a bit.